How do we know which rocks came from space? Throughout history, various cultures recorded the fall of stones from the sky, but these accounts were often considered myths or omens. The Greeks and Romans documented several instances of stones falling from the sky, yet scholars of the time generally dismissed these reports. One of the oldest surviving examples lies in Japan. In the year 861 AD, a stone fell from the sky near the village of Nogata. Local people believed it was a heavenly sign, and rather than discard it, they preserved it. For centuries, the meteorite was safeguarded in a Shinto shrine, wrapped in sacred significance. Today, the Nogata meteorite is considered one of the earliest recorded falls in human history, with a surviving specimen. Nearly a millennium later, in 1492, a thunderous explosion ripped through the skies above the town of Ensisheim, in what is now France. A 127-kilogram stone slammed into a wheat field, shaking the community. Locals saw it as a powerful omen. The stone was chained inside the local church to prevent people from breaking off pieces for luck. Now, over 500 years later, the Ensisheim meteorite remains one of Europe's most historically famous celestial relics. Then, in 1751, the skies over Croatia blazed with light as two iron masses crashed near the village of Hrashina. The event caused alarm and fascination in equal measure. The stones were recovered and transported to Vienna, where they were carefully preserved by imperial authorities, recognized not just as curiosities, but as relics of extraordinary origin. During the Age of Enlightenment, many scientists regarded the idea of stones falling from the sky as mere superstition. The prevailing view was that meteorites were simply terrestrial rocks struck by lightning. Then, in 1794, German physicist Ernst Florenz Friedrich Chladni published a groundbreaking book asserting that masses of iron and rock actually fall from the sky, producing fireballs when heated by friction with the air. He concluded that these must be cosmic objects, possibly debris ejected from planets by explosions or collisions. Today, Chladni is considered the founder of meteoritics. Ernst Chladni, fascinated by science and music from a young age, was trained as a lawyer at his father's insistence. However, he later pursued scientific research. Chladni's interest in meteorites was sparked in 1793 by a conversation with Georg Lichtenberg, a professor of physics at the University of Göttingen. Lichtenberg, having witnessed a fireball, speculated that such phenomena might be caused by cosmic bodies entering the Earth's atmosphere. Chladni began his investigation by reviewing the literature for eyewitness accounts of fireballs and stones from the sky. Over 3 weeks in the university library, he compiled what he deemed the most reliable reports, including 24 fireballs and 18 fallen stones from various countries over many centuries. The consistency of these accounts impressed Chladni, whose legal training helped him evaluate eyewitness testimony. He concluded that the witnesses described a real physical phenomenon. By analyzing descriptions of fireballs, Chladni estimated the speeds of the rocks entering the atmosphere, finding them to be enormous, beyond what Earth's gravity could produce alone, indicating a cosmic origin. Chladni also found numerous instances where fireballs were followed by the fall of rocks or iron masses. For instance, the 71-pound lump of iron fell from the sky over Croatia near the village of Hrashina, was sent to the Imperial Natural History Cabinet in Vienna, with sworn testimony from 7 witnesses in different towns who described a spectacular fireball and loud explosions. Another piece of evidence was the scorched appearance of the rocks, suggesting they had been heated enough to melt their outer layers. When Chladni published his book in 1794, many scientists dismissed it due to its reliance on eyewitness accounts. However, subsequent events shifted opinion in his favor. 2 months after his book's publication, on June 16, 1794, in Siena, Italy, numerous witnesses reported a large fireball followed by the fall of several stones. The meteorites, described as dark and heavy, caused considerable commotion, and the event was well documented, with precise reports of the fall's time, location, and descriptions of the stones and fireball. A year later, a 56-pound rock fell near Wold Cottage, England. Witnesses reported an explosion in the air, and a farmer saw the black rock hit the ground only 30 feet away, dousing him in mud. These and similar events convinced Sir Joseph Banks of the Royal Society that an investigation was necessary. He enlisted young chemist Edward Howard to analyze the chemical composition of the alleged sky stones. Howard, after reading Chladni's book and other accounts, acquired samples of the stones and iron masses. Working with French mineralogist Jacques-Louis de Bourgnon, he conducted the first thorough scientific analysis of meteorites. They found that the stones had a dark, shiny crust and contained tiny globules, now called chondrules, unlike any terrestrial rocks. All the iron masses also contained several percent nickel, as did the iron grains in the fallen stones, unlike metals found on Earth. This provided compelling evidence that the irons and rocks were of extraterrestrial origin. Howard published these findings in 1802. As scientific understanding deepened, researchers began asking not just what made meteorites different, but why. Chondrules, for example, became a critical clue. These tiny glassy spheres are believed to have formed in the early solar system when dust and minerals were flash-heated to molten droplets and rapidly cooled while floating in microgravity. In this weightless environment, the molten material naturally formed into perfect spheres. On Earth, gravity would distort their shape or pull them into other rocks before they could cool. Their very existence pointed to a birthplace far from our planet's surface. Spectroscopy offered another breakthrough. Every element interacts with light in a unique way, absorbing and emitting specific wavelengths, depending on its atomic structure. When scientists analyzed how meteorites absorbed light, their spectral fingerprints matched those of known asteroids still drifting through space. This was the scientific equivalent of matching DNA, a direct link between stones found on Earth and celestial bodies millions of kilometers away. Then came radiometric dating, one of the most powerful tools in the investigation. Certain atoms decay into other elements at a precise, predictable rate, like tiny nuclear clocks ticking inside minerals. By measuring the ratio of parent isotopes to their daughter products, scientists can determine how long the decay has been happening. When meteorites were tested, many showed ages over 4.5 billion years. No Earth rock comes close. Our planet's surface is constantly resurfaced by erosion, plate tectonics, and volcanic activity, erasing ancient evidence. Meteorites, on the other hand, remained untouched in space, preserved like time capsules from the birth of the solar system. Each discovery supported the others. Chondrules spoke of zero gravity. Spectroscopy connected meteorites to asteroids. Radiometric dating proved their age exceeded Earth's oldest rocks. The pieces fit together in a single astonishing conclusion. These were not stones struck by lightning or born from Earth. They were fragments of other worlds. We hope this video helped you discover something new. The more you learn about meteorites, the more you begin to appreciate just how incredible they are. Born in microgravity, shaped by cosmic heat, revealed through spectroscopy, and dated using the radioactive clocks of the universe. Each meteorite is a fusion of multiple scientific fields: astronomy, geology, chemistry, and physics, all working together to unlock stories older than Earth itself. At AstroPaleo, our mission is to promote science literacy, spark curiosity, and make the universe feel a little closer. We don't just sell meteorites, we share fragments of deep time and help people understand their place in the cosmos. All our specimens are 100% authentic. Classified meteorites have their photos published in the Encyclopedia of Meteorites, powered by the International Meteorite Collectors Association, and are listed in the official Meteoritical Bulletin, maintained by the Lunar and Planetary Institute. In a world full of fakes, we're committed to providing the real thing. If you're ready to hold a piece of the universe in your hand, explore our collection at AstroPaleo, where science, story, and stardust meet. Thank you for watching, and keep looking up.